Good day, learners, and welcome to today's session on KTO5, which is controlling. This module represents the final phase in the management cycle, and as we've discussed in previous sessions, the four management functions are planning, organizing, leading, and controlling, which are all interconnected. Where planning sets the goals, organizing allocates the resources, and leading inspires people to act. Controlling ensures that all these actions are staying aligned with the objectives. In simpler terms, control is about making sure what was planned actually happens. It provides a reality check for everything we do. Control is not about punishment or micromanagement, it's about effectiveness, efficiency, and accountability. It helps supervisors track performance, identify variances, and take corrective steps to stay on target. In a production environment, effective control means the difference between meeting targets and missing deadlines, between high quality output and costly rework. Without proper control, even the best plans fall apart due to inconsistency, errors, and waste. By the end of the session, you'll understand 1. The purpose and importance of control, 2. The types of control mechanisms used in production, 3. How to set performance standards that guide behavior, 4. How to measure and evaluate performance accurately, and 5. How to take corrective action to ensure continuous improvement. Now let's begin by discussing why control is vital in every management function and workplace process. Now let's take a look at why control matters in management. Control ensures that organization objectives are achieved as planned. It involves setting standards, measuring performance, comparing results, and taking corrective action. Every plan, no matter how well designed, will face obstacles. Machines may break down, employees may misunderstand instructions, or materials may arrive late. The role of control is to detect these deviations early before they cause significant losses and to bring performance back in line with expectations. In my role as production supervisor, I rely on control to maintain consistency and predictability. For example, if the target output is 1,200 units per shift and the team produces only 1,000, I don't simply record it. I ask why. Was it due to poor raw material quality, operator absenteeism, or machine downtime? Control helps me identify the cause and act on it. Control also ensures compliance with standards such as occupational health and safety, ISO quality requirements, and internal company procedures. In highly regulated industries, this prevents accidents, legal issues, and reputational damage. Control isn't something that happens only at the end of a cycle. It's continuous. It starts before operations begin, which is preventative control, continues during execution, which is monitoring, and ends with review and evaluation, which is feedback. This continuous loop ensures improvement over time. When I review performance reports and apply lessons learned to the next production plan, that's control feeding back into planning. Control connects all other management functions. It verifies that planning is realistic, that organizing is efficient, and that leadership decisions are effective. Benefits of effective control are 1. Clarity. Everybody knows what's expected. 2. Consistency. Processes remain stable and predictable. 3. Accountability. Employees understand that results are measured. 4. Efficiency. Resources are used wisely and waste is reduced. 5. Safety and quality. Standards are maintained across operations. When control is strong, supervisors can make confident, data-based decisions and not emotional or reactive ones. Now that we understand why control is essential, let's examine the different types of control mechanisms that support continuous improvement. Control mechanisms are feed-forward, concurrent, And feedback controls. Control mechanisms are the tools that help managers monitor and guide performance at different stages of a process. And there are three main types. One, feed-forward control, which is preventative control. This type of control happens before work begins. It focuses on anticipating and preventing problems before they occur. As a supervisor, I use feed-forward control when I check that all raw materials are available, machines are serviced, safety gear is functional, and that all staff have been briefed. These actions prevent disruptions and errors later in the process. Feed-forward control is proactive. It focuses on preparation rather than correction. It answers the question, are we ready to start effectively? Two, concurrent control, which is real-time control. Concurrent control occurs while work is in process. It involves monitoring ongoing activities and making adjustments as necessary. This is where I, as a supervisor, observe performance on the production floor, check machine readings, and monitor operator behavior. If I detect an issue, for example, a temperature setting outside the required range, I intervene immediately before it affects quality. Concurrent control is corrective and immediate. It answers the question, are we on track right now? Example, stopping a production line when a defect is noticed prevents hundreds of faulty products from being produced, saving time and saving resources. 3. Feedback control, which is post-action control. Feedback control happens after the process is complete. It involves analyzing results, identifying deviations, and using this information to improve future performance. I use feedback control when I review daily production reports, compare them to targets, and discuss results with my team. It helps me identify whether standards are realistic, resources were adequate, or training was sufficient. Feedback control is learning focused. It answers the question, what can we do better next time? The best managers use all three controls together. Feed forward prevents errors, concurrent detects and corrects errors in real time, and feedback improves future processes. Together, they create a cycle of continuous improvement, a key principle of modern quality management systems such as ISO 9001 and lean manufacturing. Once we know which control type to apply, we need a clear benchmark to measure performance against. That's where setting standards comes in. Control cannot exist without standards. A standard defines the desired level of performance. It's the goalpost we measure against. In a production environment, standards can be 1. Quantitative, measurable in numbers. 2. Qualitative, based on quality, safety, or compliance expectations. When I set standards, I ensure that they are SMART. S for specific, M for measurable, A for achievable, R for relevant, and T for time-bound. This makes them clear and fair, preventing confusion and unrealistic expectations. And now we move on to sources of standards. Standards are derived from several sources. 1. Organizational goals, which are what the company wants to achieve. Example, reduce waste by 5%. 2. Industry benchmarks, what competitors or regulators require. 3. Historical data, which is what performance levels were achieved in previous months. And 4. Customer expectations, the quality, quantity, and delivering standards agreed upon. Now, as a supervisor, I translate company-wide objectives into measurable targets for my team. For example, if management wants to improve efficiency by 10%, I might set a target of reducing machine changeover time by 2 minutes per shift. When employees understand how their performance links to company goals, They feel more accountable and engaged. Now, the importance of clear communication. Setting standards isn't about writing numbers. It's about communicating them clearly and consistently. I discuss standards during team meetings, display key performance indicators, which are KPIs, on notice boards, and review progress during shift handovers. When everybody knows the target, control becomes easier and fairer. Once the standards are set, the next step is to measure how actual performance compares. This brings us to performance measurement. Gathering reliable data. Accurate performance measurement depends on reliable data. As a supervisor, I collect data from multiple sources, such as daily production logs, quality inspection sheets, maintenance and downtime reports, and attendance and shift records. This data allows me to track not only output, but also efficiency, accuracy, and consistency. Data integrity is crucial. Inaccurate records lead to poor decisions. That's why I verify all data before analysis, cross-checking reports against machine readings or operator notes. After gathering data, I compare actual performance with the standards we established earlier. If performance meets or exceeds standards, I identify what worked well and reinforce those practices. If there are deviations, I investigate the cause. Common performance indicators in production are 1. Output, which are units produced per hour. 2. Quality, which is defect rate per batch. 3. Utilization, which is machine runtime versus idle time. And 4. Safety, which is the number of incidents or near misses. By consistently monitoring these indicators, I can detect trends whether performance is improving, declining, or remaining stable. Modern control systems use digital dashboards, automated alerts, and data analytics to make real-time decisions. For example, SCADA systems, which is supervisory control and data acquisition, monitor production parameters automatically, alerting supervisors to any deviations. This technology enhances visibility, enabling faster decisions and fewer errors. Now that we've measured performance and identified gaps, we need to take corrective actions to ensure that we continuously improve. Taking corrective action starts with identifying why a problem occurred and not just what had happened. If we only treat the symptom, the problem will return. Root cause analysis tools like the 5 whys or fishbone diagram help trace the issue back to its origin. Whether it's manpower, materials, methods, machinery, or the environment. For example, if defective products keep appearing, the root cause might not be operator negligence, but a faulty sensor, outdated SOP, or unclear instruction. Once the issue and the cause is identified, I develop and implement an action plan. If it's a skill issue, I arrange training. If it's a process issue, I update procedures. If it's an equipment issue, I request maintenance or replacement. Preventative measures are equally important, and this ensures that the same problem doesn't occur again. The PDCA, which is plan, do, check, and act, cycle forms the foundation of continuous improvement. 1, which is plan. Identify the problem and develop a solution. 2, do. Implement the solution. 3, check. Review the results. And 4, which is act. Standardize the improvements if successful. By applying PDCA consistently, control becomes not just a reactive process, but a proactive one. And now we move on to the human element of control. Even the most advanced systems depend on people. When implementing corrective action, I involve the team, not just to fix issues, but to take ownership of solutions. This approach builds confidence, accountability, and a sense of shared purpose. With corrective actions in place, let's conclude by reviewing how control supports success and ISA readiness. In your ISA, you may be asked to 1. Explain how you applied control methods in a production environment. 2. Identify variances and recommend corrective action. 3. Interpret performance data and evaluate outcomes. And 4. Demonstrate understanding of the PDCA cycle and its link to control. Strong control skills show that you can maintain consistency, quality, and safety under pressure, exactly what's expected from a qualified production supervisor. And now, let's recap a few of the key learning points that we covered in the session. 1. Control is the process of ensuring actual performance meets planned objectives. 2. It provides a continuous link between planning, execution, and evaluation. 3. The 3 control types, which is feed-forward, concurrent, and feedback, cover prevention, real-time monitoring, and improvement. 4. Standards must be smart, measurable, and clearly communicated. 5. Performance measurements requires accurate data and objective comparison. And 6. Corrective action and continuous improvements are essential for long-term efficiency and quality. Thank you, ladies and gentlemen, for your time today. I will see you at the next session.